So let's talk about a regular polygon. Okay, we just said it, and I got a little thing here on this program that I could, ooh, look at that. Let's make it outlined here. Let's change this to this. Let's change this to this. All right, there we go. So there's an example, one example. It's not every regular polygon, but it is a regular polygon. What kind of polygon does this one happen to be? It's a hexagon. How do we know it's a hexagon? Because 6 sides. Very good. So it's a regular polygon because all the sides are equal to each other and all the what? Angles. Okay, the interior angles are equal to each other. So let's throw some words out here that we're going to learn before we actually find the area of it. Like I said before we started recording, we know what the area of a rectangle is, right? We know the area of a triangle. We know the area of all these other things, okay? What we're going to do now is find the area of a regular polygon, all right? It could be 5 sides, 6 sides, 7 sides, 8 sides, whatever, all right? But we're going to start off, actually, let's see. Actually, we're going to start off doing an octagon. So let's do that. Let's make this an octagon instead. Sorry about that. So if I click on here, I can put 8 sides, and then boom, there it is. There, if I can grab that thing. There's a regular octagon. What's a regular octagon look like in an everyday life? It's a stop sign, exactly. Any stop sign you see is a regular octagon. All right, let's talk about, let's put the center in here. See when I highlight this thing, it gives you that little dot right there in the middle? We call that the center of the polygon. And what do you think is true about the center of the polygon? Well, if I take a line segment and I go to each vertex, do you see how those sides come together? Right? So you got vertices. So that line right there will be the same as that line right there will be the same as this one and continue. So what do you think we call that then? We usually use this word for a circle, but we can use it for a regular polygon too. That's a radius, exactly right. Okay, so on a circle, from the center, anywhere on the circle, it's the same distance, agreed? But is it the same distance from there to there as it is from there to there? No, it's longer to there, isn't it? So this is like the longest part from the center to that polygon, all right? So we call that the radius. So let's put that in. Let's just put R for radius. Is that all right? And we've got, I'll tell you what, let's put it down here just because of something else. Okay? So that would be a radius. And then if I go from the center to this vertex, what would that be? That would also be a radius. So what's true about the radii? Radii is a plural for radius. They're all going to be equal. Exactly right. Okay? That's going to be equal to that. And I could do it. And how many radii, again, that's the plural, how many radii do I have on a regular what? Octagon? I got 8 of them. Right. I could do this 8 times, couldn't I? And I got 8 radii. Everybody with me? Now, here's another one. I'm going to do it in a different color because you probably haven't heard of this one before. My guess is nobody's heard of this one before. But if I go from the center of the polygon, not just anywhere along here, where do you think a special place would be along here? Yeah, not just middle, but what? Hits it at a right angle, so it's a what? Perpendicular, right? Yes. Hadn't been that long, has it? So if it hits perpendicular to any of the sides, I could have drawn it perpendicular to this side, I could have drawn it perpendicular to this side, any of the 8 sides, I could have drawn a line perpendicular to it. But we have a word for it, and this is a new word that my guess is you probably never heard before, and it's called an apothem. A-P-O-T-H-E-M. Apothem. All right? Am I correct? Nobody's heard this word before? You have heard it, Kate? Good. She has that Fairwinds education. That's probably why. Is that what it is? No? Where did you learn apothem? Any idea? You just heard of it? That's fine. Probably. Yep. Anyway, it's called an apothem. Now you've heard of it. Okay, so if you go to another school, you go somewhere else, they say apothem. You're like, Mr. Hammer told me that. Red line. Yay, red line. All right, so anyway, there you go. That's an apothegm. What we're going to do is, did they do apothegm just yet? Oh, yeah, they do. But I got to teach a couple other things first. All right, so we'll get back to the apothegm. So we've just labeled these things right now. Again, that's perpendicular. Now, what do you think happens? Somebody said it earlier. What do you think happens to this side right here, that pink one right here and this side? Where do you think it hits? It hits perpendicular. It hits in the middle, right? It hits at the midpoint. That's right. So it bisects that side right there. Everybody see it? All right, and that's true. So if this whole thing was 8, what would this be right here? It would be 4. Okay? So when you go perpendicular to this on a regular polygon, when you go perpendicular to it, it does bisect it. Everybody good? All right. And that's because you got congruent triangles and their corresponding parts are congruent triangles and all that good stuff. All right. So let's do this. I'm going to keep the octagon, and I'm just going to draw something else with it. Let's scooch this out of the way. Let's put that right there again. And let's do this. And I'm going to go from here. So it kind of looks like the same, except I'm just not going to put the apothegm in here just yet. Let's see. Okay. Do you see the angle that's formed between those two radii? This one right here? We give that a name. Okay. By the way, that little dot right there, see that point? We call this the center. And I've said it a few times, but I'll just write it down. It's called the center of the polygon. This angle, since the vertex of the angle is at the center, we call this the central angle. Okay? So why do we call it the central angle? Because the angle, the vertex of that angle is where? It's at the center of the polygon. Everybody see it? Okay? So is this a central angle right there? No, that's not a central angle because the angle is at a vertex. Okay? This is a central angle right here because the vertex of that angle is at the center of the circle. So that's pretty important. What do you think might be true? I'll put a 1 and a 2. What do you think might be true about 1 and 2? Yeah, they're equal to each other. And there's a reason for it. Again, if you came over here, these would be congruent triangles. So what would be true about this angle and this angle right there? They would be congruent to each other. Because if they're congruent triangles, you folded them on top of each other, they would be the exact same thing. Agreed? So angle 1 and 2 are equal to each other. So we know that. Let me get rid of this. Okay? So what I want to do, I'll tell you, let me keep going. I'll show you. There's a reason why I'm doing this. I'm going to draw all the radii just to kind of, so we can come up with this next little formula. Okay? Now, how many sides did I say this thing has? It's got 8 sides. What I want to do with just that information, with just me telling you that you have 8 sides, you should be able to figure out what this angle right there is, what the central angle actually is. Any ideas on how to do it? So this angle, tell me something that's in common with all these angles or unique about it, or what, I don't know how to phrase it. What's true about all these angles? They're what? They're all equal to each other, exactly, okay, because they all form congruent triangles. So all these angles are equal to each other. How do I find the actual measure? I want the degree measure. I want a number on, how did you figure that out? Okay, you could do it that way. That's a good way to do it. Why 180? Because that's a straight line right there. It's a diameter, right? So all 4 of these angles add up to 180. It's not always going to be true that you're going to have like a diameter in there. So how many degrees altogether? What do all those central angles add up to be? 360, because it kind of makes a circle, doesn't it? right? It starts here and it goes all the way around back to where it starts again. So we have 360 degrees. Divided by, how many angles do we have? If I got 8 sides, I got 8 central angles, don't I? So I could go 360 divided by 8, and that also gives you 45 degrees. So Kate's absolutely right. She went from here to here. This is 180. There's 4 of them, but it's basically just doing it like just twice as much, right? Twice 180, twice 4. And there we go. Let's see if anybody's thought it was a real text. Somebody want me to give money for Donald Trump, so he won't get any of my money. So, well, none of them will. I don't have money to give these guys. So, all right. So now, once we know that angle, that's 45 degrees. What do you think we're going to find now? I've already named them. 1 and 2, exactly. And what's true about 1 and 2? They're equal. They're the same. Okay? So what do you think I could do? I'll tell you what. Since they're the same, let's name them the same. Let's just name it X. Is that all right? I named them both X. Why didn't I call one X and one Y? Because they're both exactly the same, right? So I don't need to give them different letters, do I? All right? So I didn't. That's why I didn't want 1 and 2. So if this is X and this is X, how in the world do I find what X is? Well, look, I've got a triangle now, don't I? Everybody see that? So I've got a triangle. So X plus what? X plus 45 equals 180. Everybody see that? Here's the triangle right here. Those 3 angles of the triangle add up to 180. So I add them up. X plus X is 2X. And then plus 45 equals 180. So subtract 45 from both sides. What's that? 135. And then divide by 2. Right? So these two, these two add up to 135. But if I want to find each of them, then I take that 135 and do what? Take half of it. Okay? And then you might not be able to do that. I did it already. 67.5 degrees. So that angle is 67.5. That angle is 67.5 degrees. Does that make sense? So we actually have a little theorem. See this thing right here? We actually figured that on our own, but they actually have a theorem. I don't think they named the theorem. At least I didn't name it in my notes. I'm not going to write the whole thing out, but basically what it says if you want to find the central angle of any regular polygon, what are you going to do? You're going to take 360 degrees, divide it by what? Let's say it was a hexagon. What would you divide it by? 6. What if it was a decagon? What would you divide it by? 10. Okay? So what if you don't know how many sides? We call it n. We usually call it n number of sides. So it would be 360 what? Divided by n. So that gives you the central angle for any regular. It's got to be regular, okay? All the sides and all the angles have to equal each other. This does not work if it's not regular, okay? So if all the angles and all the sides are equal to each other, in order to find the central angle, let's write that down. The central angle is equal to 360 divided by how many sides you have, all right? So without even drawing anything, if I said you had a decagon, we'll use that since we talked about it a second ago. How would you find the central angle of a decagon? The central angle. Well, what's the formula? 360 divided by 10. Why 10? That's it. A decagon's got 10 sides. You can do that math easy. What is it? What's the central angle on a 10-sided figure? It's 36 degrees. Everybody got it? How would you find the other two? We call these the base angles. How would you find the base angles? Well, you would go what? 2x plus what? 36 equals 180, and then do the math. Everybody got it? You don't really even need the picture, do you? We do the picture so you can visualize it at first, but then if they just ask you what is the central angle, you should be able to know to divide it by take 360, divide by how many sides you have. Make sense? Good. Tim, you getting all this? Sorry to wake you up, but, you know. All right, let's flip the page. Now, the apothem. Why do we use that apothem? Well, I'm glad you asked. Let's do one where we actually use the apothem. This is where we're going to do the area. Have we even talked about the area yet? Not yet, okay? But the stuff that we used already is going to help us find the area, all right? You know that usually happens in a math class, don't you? So let's change this to 5 sides. And we got a regular. What's pentagon? Oh, come on. Why can't I grab that thing? There it is. I don't remember it being that difficult to grab this. I think they might have changed something in this program or something. I don't know. So what we're going to do is this. We are going to find the area of a regular. In this case, it's a what? It's a pentagon. But we need a formula. And I'll just give you the formula. I'm not going to ask you to guess it or anything else, okay? I'm not going to show you how we came up with it, okay? We're just going to give it to you. It's actually pretty simple. It's a pretty simple formula. So make sure you write it down. So the area equals, kind of starts off like a triangle. Remember what area of a triangle was? The base times the height. So it starts off with a half, and you are multiplying two things together. But here's what you're going to multiply together. You're going to multiply the apothem times P. What do you think P stands for when you're talking about these figures with straight sides and all that? If I was going to go around an object, it's the perimeter. Very good, okay? So the perimeter is the distance around this whole entire polygon. Everybody with me on that? All right, that's what the P stands for. So if you need to, write it down. That means the apothem. And again, what is the apothem? The apothem starts at the center. It goes perpendicular to one of the sides. That's the apothem. This P right here stands for perimeter. And what's the perimeter of this thing? How do I find the perimeter of it? Like if I knew the length of this side, let's say the length of this side was 5. What's the perimeter of that? Do I want to use 5? It doesn't. I'll tell you what. Oops. Let's use S for side. S for side, okay? So what's the perimeter of this figure right here? If it's a regular pentagon, what is it? 5S, that's right. So it's just 5 times the side. What if the side was, just making a number up off the top of our head, let's just say that was 7. What's the perimeter of this regular pentagon? Say it. Give me a number. Give me a number. 35, okay. I hear a lot of whispering. I can't hear what you're saying. I'm an old guy. My hearing must be going, I think. All right, so it's 35. So the perimeter would be 35. Everybody good? Okay. What if the perimeter was 10? Actually, no, let's not do that yet. I just put that pentagon there just to show you this. But here is the formula. That's what you got to know. You got to memorize it. It's not hard to memorize, is it? It's kind of like triangle because you got 1/2, then you got multiplied by 2 things, right? But what are the 2 things? It's the apothem times the perimeter. The perimeter is usually pretty easy. If they give you one of the sides, the perimeter is pretty easy to find. You just take whatever the side is, you multiply it by whatever your figure is, right? If it's pentagon, you multiply by 5. If it's a hexagon, you multiply it by 6. Octagon, multiply by 8, and so on, okay? It's the apothem that's the one that we have to think about a little bit, all right? Are you kidding me? I was just getting on a roll. Well, goodness, I left the best part out. Well, we're going to figure out how to find the apothem. So let me just do a little picture. So what is the apothem to this? It's that length right there, okay? That is the apothem. So we're going to do a little more work tomorrow with it. Sorry we didn't get finished. I broke it down into 2 parts anyway, so it worked out fine. So listen, hey, what's going on? So the official assignment is 5 through 12. I don't have the book in front of me. I'm not sure if you're going to be able to do a whole lot of these. There might be a couple of these you can do. Do as many as you can, okay? Do as many as you can, and then we'll finish this up tomorrow.